Alright, central limit theorem. This is actually a pretty straightforward idea, I think. Yeah, but I think it's pretty cool. Anyways, learning targets. You're going to be able to tell yourself, I can explain how the shape of the sampling distribution x bar is affected by the shape of the population distribution in sample size, and I can use a normal distribution to calculate the probabilities involving x bar. Dun dun dun. You might think to yourself, oh, this sounds like kind of like stuff we've been doing already, but it's a little bit different. So what is the central limit theorem? When n is large, the sampling distribution of the sample mean x bar is approximately normal for any population distribution. You can kind of see from that picture right here. Let's see. As n increases, you have n equals 1 as that squiggly line at the very bottom. And it starts to look more normal as n increases. Pretty cool. So again, the bigger the n, the more normal a curve is. So what does this mean for a sampling distribution? If the sampling population distribution is normal, the sampling distribution is normal. If the population distribution is not normal, the sampling distribution is normal if the size of each sample is greater than or equal to 30. It's pretty cool. That's pretty cool. So that means basically if the population is normal, the sampling distribution is normal. If the population distribution is not normal, the sampling distribution is normal if the sample size is greater than or equal to 30. And you'll probably see like your mom's like, well, when do we know it's not normal? Like they won't like not tell you it's not normal. The questions that I will give you and the questions the AP exam will give you will say whether or not a population is normal or not normal.
Is anyone doing this?
Alright, so pretty basic idea. And we're going to look more into this in class the next time. So example 1, your company has a contract to perform preventative maintenance on thousands of AC units in a large city. Based on service records from the past year, the time and hours that a technician requires to complete the work follows a strongly right skewed distribution, aka not normal, with a mean of 1 hour and a standard deviation of 1 hour. In the coming week, your company will service an SRS of 70 AC units in the city. You plan to budget an average of 1.1 hours per unit for a technician to complete the work. Will this be enough? Well, let's check it out. So essentially, we are looking for the probability that the average maintenance time, x bar, exceeds 1.1 hour. 1.1 hours. So show your work. So step 1, state the distribution and values of interest. The sampling distribution, the sample mean, time, x bar, spent working on 70 units has, again, the mean of the population is equal to the mean of the population. And so that is going to be 1 hour. And the standard deviation is going to be standard deviation of the population divided by square root of your sample size, which in this case is 70. Our standard deviation 1 is equal to 1, so it would be 1 divided by a square root of 70. And when you plug that into your calculator, you get 0.1195. Pretty neat. It's really important that we check our conditions. Remember, our 10% condition is our sample large enough. 10% condition. N is 70, and 10 times 70 is less than the population of all AC units. So we're good to go in the large enough condition. And while the population is not normal, because sample size is greater than 30, our sampling distribution is a normal distribution. So whenever we end up having to use the central limit theorem, you're going to add that extra condition that I just wrote, that very last bullet. So be sure to include that as well when you answer these questions. Step 2, perform the calculations. Lower bound 1.1, upper bound a really big number because you're looking at the probability of it taking longer than 1.1 hour. The mean is 1, and our standard deviation is 0.1195. So when we plug that into our calculator, we end up getting 0.20. So that means there is a 20% probability. So step 3, if you budget 1.1 hours per unit, there is about a 20% chance that the technicians will not complete the work within the budgeted time. 20% chance. These are decisions that many companies have to make all the time. So, do you think 20% is worth it? Dun dun dun. Crazy. But yeah, and so I'll leave you guys thinking about that. How can statistics show us the probability of our decisions? All right, I'll see you guys later. See you tomorrow. Catch you later. Catch you on the flip side. Okay, bye.